Number six. Number six here. So they're giving us a bunch of graphs, and they want us to figure out which one. So it says up here, let me write it like it looks on your screen. So f of x equals 2 to the x power is black. K, they're using instead of B because they didn't want to confuse black with blue. So they used K for black. So that means it's this graph right here, this one right here. I'm going to scribble it. That one is the function f of x equals 2 to the x power. We call that an exponential function. So we'll do more of those kind of graphs. We'll do a bunch of them in a few chapters. We'll do a whole chapter devoted to exponential functions. So let me write that word out. Exponential function. X is an exponent, right? It's up in the power zone. X is a power, an exponent. So we call that an exponential function. When x is up in power, x is an exponent. Okay, so it's an exponential function. And that's what it looks like. And we'll talk more about that later, about why does it exactly look like that, and how do you alter it, and all things like that later on. So now, for now, what we want to figure out is what's going to happen if you put like a negative in the front. In fact, let me write these out like a little bit better, like they look on your screen. So this is negative 2 to the x. This one is 2 to the negative x, and this one down here is negative 2. Oh, I should have used the parentheses on the last one. Oh, that was not a good move. There we go. So, yeah. So, what's the deal? What happened? Basically, the whole question is what happens? What is the effect of a negative on x or y? That's what we're trying to answer here. What is the effect of a negative on x or y? Well, negative, let me just write it out for you. Step number 1. A negative on x, well, a negative number multiplying x flips the graph sideways. It flips the graph sideways. And number 2, so that would be like y, or that would be the y. That would be 2 to the minus x. That'll flip it sideways. And then case 2, a negative number multiplying y. And how do you multiply y? The front of the function. Flips the graph vertically. Flips the graph vertically. So that would be like, so here, let me go back. This is y equals. That would be like y equals negative in the front there. So this one here, that's a negative on x, as you can certainly tell. And this one is a negative on y. That one's a little more like, why is it on y? It's not really on the y. Well, the truth is you could multiply by both sides by -1, and then it would be over there by on the y, and that wouldn't change the equation at all. So it's the same as being on the y, right? Because it's not on x. So that's how you want to think about these things to make it easiest for yourself. Just basically ask yourself, is it right on x? Is it right in x's world, right in x's face? If so, it's an x. If it's somewhere else, not right on x, right in x's little power world, then it's a y by default. It's a y. Did it make sense that I said you could multiply both sides by -1? I don't want to confuse you, but hopefully I made sense there. If you multiply both sides of this equation by -1, which doesn't change anything, right? If two things are equal and you treat them the same, add, subtract, multiply, or divide, same thing on both sides. You're not changing anything. You're just changing the way it looks, right? If two things are equal and you treat them the same, they got to be equal, same afterwards. Well, you see what that would do? That would make it -y, and then the two negatives here would make it plus. So now the minus is on the y, which remember is the same as this. It just looks different because I did the same thing to both sides, which proves it's really on the y. That's the same as it being over here. I just wanted to show you why that really means. It's effectively on the y. You could multiply both sides by -1, and it would physically be on the y if that would help you see it. All right. So it's either right up there on the x, or it's in the front, which means it's really on y and has a vertical effect. If it's on the x, it has a sideways effect. Okay. So let's take a look, see here. So how about, let's start with this first one here. -2 to the x. That minus sign, let me write it out here. So that minus sign, is that an x or a y?
That's a y.
This minus sign, it's on y, vertical flip. Which graph has simply been flipped vertically? What do you mean? Remember, starting with this is the original. Yeah, I hope that's becoming clear to you. You've always got to start with whatever the base function is, the original basic graph. So the original 2 to the x, that's what this all starts with, right? All these are variations of 2 to the x, aren't they? So we're starting with the basic base 2 exponential function. So starting with that, which looks like this, starting with that, and then start putting negative signs different places and see what it'll do. So if you're starting with this, which is that, and you put a negative right there, which is a vertical flip, because that's a y, it's on y, vertical flip. Which graph is a vertical flip? You take this, oops, you take this, and you vertically flip it. Do you see it's going to be this one here? It's the R. So that's going to be the red one, the R. That's been vertically flipped. So you just grab this graph and flip it down there. Okay, let's go on. What about the second part? What about the second one? So the second one is to the minus x. So that minus sign, this minus sign, that negative is certainly on x. It's clear as day. That's on x, which means it's a sideways flip, right? So which one of these graphs, going back to the original black graph, right here, that's the starter, starting from the basic 2 to the x and then popping a negative on the x. It's going to flip it sideways, so that's the blue. See how the blue's been flipped sideways? That's the blue. Finally, last one. Negative on the 2, and negative on the x. That's both, isn't it? Everybody see that? Negative on y, negative on x. So we got negative on x and negative on y. We got negative on both. So what's that going to do? That's going to flip it both. Flips sideways and vertically. Sideways and vertically. So which graph? Obviously, there's only one left. But would you be able to do it if it wasn't? Which graph has been flipped vertically and then flipped sideways? The G. Everybody see that that's exactly what the green graph, G for green, has been done? See how they took this original one and then they flipped it down and then they flipped it sideways. They did both. So that is the green graph. And so there we go. So what we see is multiplying by x, a negative number multiplied by x, or a negative number multiplied. This is multiplying, notice. This isn't the same as adding a negative one. That would just move it right one or left one or up one or down one. Well, I guess it would be down or right, depending on if you did it with x or did it with y. But anyway, it wouldn't flip it. Flipping is only when you multiply. A negative is multiplied. So when you multiply by a negative number on x, it flips it sideways. If you multiply by a negative number on y in front of the function, it flips it vertically. If you do both, it flips it both sideways and vertically, like we saw on this one. So multiplying by a negative number, multiplying, not adding, subtracting. Adding, subtracting moves graphs. Multiplying by -1 flips graphs. That's what we're seeing.